So we're going to be looking at the last part that consists of division as well as powers of j, and then concepts regarding polar form, that is the multiplication, division of polar forms. So before I start, I just wanted to look at the concept of conjugate. Conjugate for an expression, conjugate for an expression of the form x plus a. The conjugate is written as x minus a. So as you can see, the only difference is that at first, the first expression, we had a positive sign, and then with the conjugate, we have a negative sign. So if you look at the example, have the first expression, which is x plus 3, and then its conjugate is going to be x minus 3. Second expression, I have 2x minus 5, and then the conjugate of that is going to be 2x plus 5. So the only difference is the sign changes. So where am I actually going with this? So since we are dealing with complex numbers, let's look at the conjugate. If I have a rectangular form of, let's say, z is the same as a plus minus bj. So this is to say, if I were to write the conjugate of this, then I'd say z, which is, I'm going to use a z with a cap on top, just gonna say a cap here, to represent a conjugate. It's going to be a remain as it is, and then now remember that we wrote plus minus, so now it's going to be minus plus bj, right? That is to say, if I had z is the same as a, let's say, plus, no, I don't want to use that. So let's say I have z is equals to 1 plus j. So the conjugate of this would be, 1 minus j. That's it. You only change the sign. So where am I going with this? If I have division, let's say if I had z2 over z1. Remember the previous examples? Z2 was negative 3 plus 7j. And then here's going to be z1. So z1 was 4 minus 2j. So if we have something of this nature, you cannot say you're going to divide, let's say 3 divided by 4. You're not going to split it apart. No, you're not going to do that. What you need to do here is to multiply the denominator with its conjugate. You want to get rid of the conjugate, because once you multiply this expression with its conjugate, you're going to get a real number. You understand? So let me do a quick example before we dive into that. If I have a multiplication of an expression multiplied by its conjugate, let's say now, remember that I'm just going to use the very same example that I used above. If I have 1 plus j multiplied by its conjugate, which is 1 minus j, let's do the math and see. 1j, so you have 1 and then minus j, and then here you have what? You have plus j and then minus j squared. So 1 and then minus that, it's out, cancel each other, and then you're going to be left with minus j. So remember what we said with a letter j. J is the same as the root of negative 1 squared. So that if you're going to get rid of the square root, it's going to be 1 over 2 multiplied by 2, 1, negative 1, 1 over 2, 2 over 1, cancel, so that you'll be left with 1, negative 1 multiplied by negative 1, that's going to be plus 2, so plus 1. So your final answer would be 2. That's it. So you ended up with what? With a real number. So let's do the same with the denominator. Let's try to multiply this with its conjugate. So we had negative 3 plus 7j divided by 4 minus 2j multiplied by the conjugate of this denominator, which is going to be plus 2j. And then remember, if I'm going to multiply the denominator with this conjugate, I'm going to have to do the same with the numerator, which is going to be 4 plus 2j, right? Now, let me just close the bracket. Let's focus on the numerator. Then we have 3 multiplied by 4, it's going to be negative 12, and then 3 multiplied by 2, it's going to be minus 6j, and then 7 multiplied by 4, that's going to be 28 plus 28j, and then here we have let's say 7, and that is going to be 14j, and then it's a j squared, right? And then denominator 4 and 4, it's going to be 16, and then 4 and 2, that's going to be 8, and then negative 2 and 4, that's going to be minus 8j, and negative 2 and j, negative 2j, it's going to be minus 4j squared. So if you say 28 minus 6, that's going to be 22. If you can drop this negative 12, and then you're going to be left with minus plus 22 here, j plus 4, and then remember j can be written as negative root 1, the root of negative 1 squared, divided by 16, and that cancel, going to be left with 4 root of negative 1 squared. And then let's see, if I get rid of this, then obviously this whole thing is I'm going to be left with minus 4, so plus 22j, and then because you're gonna get rid of the square root, and then be left with negative 1, and then minus 4, all divided by this, the same 16. What did I do here? Okay, 16, and then I got rid of that, and then minus here, remember, you're going to be left with minus plus 4, right? And then what are we left with? If you look at the numerator, you have minus 12 minus 4, which is minus 16 plus 22j, all divided by 16 and 4, it's going to be 20. 16 divided by 20, 16 divided by 20, it's going to be 4 over 5, 4, negative 4 over 5, and then plus, let's say 22 divided by 20, that's 11 over 10, and then j. So this is the final answer that you should get from dividing. And then you can further, let's say now if you have a sharp ELW506, then you can simply go to mode if you want to confirm your answer, and then you'd say complex 3, and then if you, let's see, what are we going to get? If I say -3 plus 7 j, which is I'm going to, it's I in this case, right? Divided by everything, brackets, and then divide the whole thing by 4 minus 2j. Then I want the answer in polar. It should be in polar form. So that simply means 1.3, 1,3. Can I change this? No. So it's 1,3 plus 1,1. It's -1,3. So let's see. 4,5, 0,8. I think somewhere along the way I made a mistake. So I'm going to sniff out the mistake that I did with regards to this. I think somewhere along the way I did a mistake. Where is the mistake that I did? Where is the mistake that I did? Okay, let's look at this. Negative, that sharp, and then 7, and okay, this and that gives you 12. Then this and that gives you -6. Okay, sharp, and then this 7 and 4, right? Yeah, 7 and 4. Where did I make a mistake now? That's 28j, and then 7 and that's 14. The numerator is okay, and then 4 and 4. Where did I? 16, right? And then 4 and 2, that's 8. 2 and that's 8, and then -2 and that is negative that. Cool. Now let's look at that. 28 minus 6, it's 22. Hide that up. All right, and then plus, oh yes, instead of 14 I wrote 4. That's where I made a mistake. 14, so it's supposed to be 14 here. So minus 14 minus 12. That's why I made a mistake. It's supposed to be 26, -26, -26 here, and that. Okay, and then same applies. Now let's see if I say 26 divided by 20, 26 divided by 20, that's 1.3. So just have to get rid of this, and then 1.3. Can I change that? No. 1.3 plus, and then if we say 22 divided by 20, that's 1.1 j. So again, if I have to check it with the calculator, -3 plus 7, you close that, and then you divide the whole thing with 4 minus 2i, right? Close that. So this is correct. That's what I got. So now I want us to look at let's say, what's this? Yes, I want us to look at the powers of j, powers of j, or powers of I. Powers of j, right? So now I'm just gonna do a couple of examples. A, I have J3. So if I have J3, I know I can write J3 in 2 multiplied by J1. So we know for a fact that J2 is going to be what? J2 can be written as -1. We did that, and then multiplied by what? By J, so that the final answer could be -J. So let's say now if I have another example, J20 to the power 27. So I can just do what? I can just split this into 26 and 1. J26. I have to change this odd number to an even number. Okay, that's what I did, J1. And then this even number, if I divide it by 2, so if I divide 26 by 2, I know I'm going to get 13. So 2 to the power 13, J, and then let's say if 26 can be written as 2 to the power of what? Of 13. Understand? Multiplied by J, which is, remember now, if you have J2, that can be written as -1 to the power 13, which is, it's still 1. And then I'm going to remain with -J still. So that's how you can play around with the powers of J. So let's say now I have 2J to the power 2 multiplied by 3J to the power 29 multiplied by 4J to the power 3, all divided by J to the power 5 multiplied by J to the power 7. So with this in mind, I'd say the bases are the same. If you have J, you can just do what? You can just say 2 times 3 times 4. 2 times 3 times 4, which is going to be 24. If we look at the coefficients alone, and then the bases are the same of the exponents, so you can just take 1J and then add the exponents, which is going to, if you add 29 and 2 and 3, you're going to get 34, all divided by, you do the same with the denominator, add the exponent, 5 and 7, you're going to get 12. You're going to get 12. So with that in mind, you can just subtract numerator 24J and then 34 minus 12. You're going to get what? You're going to get 11. If I'm, yeah, going to get 11. 34 minus 12, you're going to get 22. But remember that 22 can be written as any number. 20, let's just say 22 divided by 2, 11. So you can write this as J to the power 2 to the power of 11. But you know for a fact that J2 can be written as what? It can be written as -1 to the power of that. So all in all, you're going to have a -24. So for you to try, you have to try at least following. You have at least try this. Try, please, and then you can just drop your answers. And then you have 1J to the power 3 plus J to the power 5, 3, 2, 5. That's the first one. And then number 2, you have J squared multiplied by J 1 plus J 5, 3, 2, 4. What am I doing? I think I was actually solving this, but you can just try that first one. All right, so let's look at the last part. The last part, it's just going to be the multiplication and division in polar form. Remember the previous part, we were dealing with multiplication and division in rectangular form. So what happens now if you have z1 is the same as r1 with an angle or argument of that theta, and then secondly you have that. So if you are required to multiply the two, then z1 multiplied by z2, you're just going to multiply your r1 and r2, you multiply those two, and then you add the two arguments. So you multiply the modulus, two modulus, and then you add the angles. So that's the rule. And then even if you're going to divide, if you have z1 divided by that, you're just going to divide the modulus r1 and r2. You just have to divide the two modulus r1 and r2, and then you subtract the angles, or what we call the arguments. So angle 1, or argument, the first argument minus the second argument. And then if you are dealing with exponents, in polar form, let's look at this one. You have a polar form raised to the power n. So what is it that you're going to do? r1 to the power of n, and then you multiply that n with the argument. So that's that. So even if you were given in rectangular form, you're gonna have to convert this rectangular form to a polar form, and then you can apply the same steps that we just did above. So can you please try the following? Simplify and leave your final answer in rectangular form. You have the first one, which is z is equals to 2 to the angle of that 30 multiplied by 10 angle 45 divided by 5 angle negative 25. Second one, now you have to be careful with this one. If you are given your angles in radians, make sure that your calculator as well is in radians. So if you want to confirm your answer. Okay, and then the third one, you have 3 with an angle of negative 45 cubed, and then everything is cubed, and then divided by 2 negative angle negative 30 to the power 4. And then lastly, you have that. Please try these 4. Then, yeah, I think this brings us to the end of this chapter.